Now we know where nuclear fuel comes from, we can gain an understanding of the components and structure of a nuclear reactor. The fuel plates are contained within the reactor core. In between the fuel plates within the core is control rods, which are made of boron or cadmium, and are neutron deficient, so they attract and absorb neutrons in order to slow and stop the fission chain reaction. There is a lot of careful planning of the position of fuel rods and control rods within the core, so precise conditions for controlled fission chain reactions can be established. The reactor core is located within the reflective vessel. Placed within the reflective vessel are the irradiation facilities containing targets used for fission and neutron activation. There are two types of targets in a nuclear reactor for generating radiopharmaceuticals. Neutron activation targets are made of stable nuclides. Common targets contain either phosphorus-31 or strontium-88. Their products are used in radionuclide therapy. These targets are inserted into the reflective vessel via pneumatic systems. The pipes of these pneumatic systems can be seen running down the wall of the reactor into the reflective vessel. Molybdenum-99 targets are made of fissile material, and these targets are manually loaded from the operation bridge into the reflective vessel. Moderators are also contained within the reflective vessel. Moderators such as H2O, D2O, and graphite are used to thermalize neutrons and reflect neutrons back into the core in order to increase the probability of fission reaction. D2O is also known as heavy water, where hydrogen has been replaced with deuterium. The reflective vessel sits at the bottom of and is surrounded by the reactor pool, which is usually 16 meters deep, containing water which acts as a coolant and radiation shield. The water in the reactor pool is of a very high quality, allowing for clear visualization of components inside the pool during setup and operation, and prevents corrosion of those components. Next to the reactor pool is a servicing pool, where fuel, tools and equipment used within the reactor are left to cool off. In some reactors, the reactor pool is open so you can see right down through the water to the reflector vessel. The reactor is encased by reinforced concrete, which is contained in a building structure that is designed to withstand earthquakes or light aeroplane crashes.